Great. Thank you, Anne, and thank you, Cassandra, 2030 District, Unico, everybody who put this competition together. Just putting up a slide here. I think everybody knows about the competition. You can go to the website to learn a bit more. This is, I think, the first one for the 2030 District. And so our team, District Carbon, did take the 1111 3rd Avenue, a Unico operated property. This is the team, so between ZGF, Stantec, KPFF, and Lease Crutcher Lewis. And big shout out to Juliana Plant, who started this ball rolling down the hill, and the team expanded over the summer and includes a great group of subcons who did pricing. So, really from the start of this project, the team looked at, the big picture of the district and how we're looking at, COVID, climate change, market instability, the next big earthquake. And then also not just looking at scope 1 and 2, but also scope 3 greenhouse gas emissions. So from transportation, embodied carbon of building materials. It was clear that looking at the data, the transportation carbon was the dominant carbon. And so that kind of shifted the thinking outside of just our parcel and really looking at the district and the city. And so operational carbon really was the smallest piece of this pie from right out of the gate. And certainly with the decarbonizing electric grid, that was not the largest emphasis for the team. We also were looking at, downtown zoning and opportunities, and interesting, the Dock 1 high-rise zoning. It's predominantly office, but it encourages increased residential for growth management and housing policies. So we were asking, how can the zoning in the city further incentivize a holistic approach to adaptive reuse? We're looking at the latest Washington State Clean Building Bill, future greenhouse gas targets. So how are we thinking about all these different layers of seismic upgrades, reclads, MEP systems? How can those all go together? So the existing building, our big move was to shift about 80% of the office program to residential. So the existing is primarily office with a podium plaza with retail. And so our goal was that 10% of this housing would meet the mandatory housing authority as a minimum, and that this residential would certainly trigger increased open space, which ties in well with 3rd Avenue vision, which looks at really activating 3rd Ave as one of the busiest transit corridors in the United States with more open space. It also going to resi would trigger more amenity and recreation. So this diagram starts to show how we're apportioning that program. So Juliana.
Yeah, great. So it was really fun to kind of think outside the box and reimagine possibilities for this building and think about it. And when we were doing that, we started looking at, the phases, both from a constructability standpoint and looking at the final kind of concepts that we had come up with and thinking about what made sense first, what was the most impactful, and then kind of the sequencing and wanted to think about, how to convert office into residential. And so we phased it into 4 projects. We looked at starting it right away, just for ease of kind of trying to do pricing and information, but really wanted to look at a holistic approach of the pre-construction, design, and the construction cost, including all the general conditions and street use and things like that, as part of this kind of outlook of the overall phasing. And so we have a cash flow for each phase kind of and how things overlap. And we'll be going through each phase a little bit. I think you can go to the next slide. So the first phase really was in enhancing upgrades for the electrical infrastructure, really starting to move things down to ground level for the electrical as opposed to up in the building. It's a little more typical of what's expected from Seattle City Light. The next one, I think
Yeah,
Daryl.
I'll jump in here. So,
Yeah.
kind of the big thing here was we were looking at kind of a core need communicated by Unico. They had said that their electrical system was really nearing its end of useful life. They were having some issues getting replacement parts, and so that became a core criteria in a path forward for us. So looking at that, we decided that the entire electrical system needed to be replaced. And as we worked our way through the program shift from exclusively office to a more mixed use, our load calculations really suggested we needed more capacity from the utility. This is already an all electric building, but we were really driving that up with some other new things like electric vehicle charging. And so we decided to take some real estate in the garage and also build that system to allow connection points for on-site renewables and other things that are going to plug in the future, like battery energy storage. At this point, we want to put some battery energy storage in the building to build up resiliency and offer some peak demand management, but also with the idea that it can grow into something more that can drive us away from a fossil fuel-based backup generator in the future. And then also trying to smarten the electrical system by adding metering and control. So really trying to take a microgrid approach at a building level. So as you start implementing more energy sources, you can do better control and monitoring of the power within the building, really with that idea of being able to implement demand response later when the utility is ready, or if it's something that really wants to be managed on a building level as it relates to the tenants.
Great. So we tried to take a look at each phase and get pricing together because we wanted to try and get a mixed bag on how things could go together. As I talked about, we took an approach of pre-construction design permitting, as well as the implementation of the systems and the support work that needs to go through it. Phase one was a 5-month construction and looking at, hypothetically starting right now. And it would be an independent phase that could be done. And then the other phases could potentially go down the road. But it starts to free up amenity space at the upper levels and is really the baseline for the next phases that go through. But there's a long way just by doing this infrastructure upgrade that we saw success with.
All right, so phase two, I'm going to touch a little bit on our approach to the structural systems in the building envelope and talk a little bit about the synergies we gain by looking at these two systems together. So the existing structural system, it's a steel frame building, and the lateral system that resists the wind and seismic forces are steel moment frames around the perimeter of the building. And the envelope system is a precast concrete panel with an insulated backup wall. So a big piece of our story is in the holistic review of the building systems and the benefits that we get when we kind of look at them all together. And an upgrade to the envelope to improve the energy and performance of the building is also a great time to review the lateral systems. And the two big advantages that we get when we look at these two systems at the same time is, number one, upgrade to the building envelope allows us to put something that's much lighter on the outside of the building, and just reducing that mass alone gives great improvement to the seismic performance of the building just by taking mass off, which is great. If we further evaluate the building and find that we still need some improvements, another great way to do it is to add dampers. And so if we're pulling off the envelope, it gives us great access to the building and it makes the construction of that system a lot easier. So our approach to these systems is to lighten the load by replacing the envelope and then add damping as required. So two projects that serve as a great proof of concept for this are the Edith Green Wendell Wyatt modernization project that was done, and then also the Nines Hotel. The Edith Green project in particular is very similar to our building. They had heavy cladding that was replaced, And they were able to do the seismic upgrade without actually even adding dampers on that project. So super encouraging. All right, that's what I have.
So yeah, reskinning the building, would need to satisfy budget schedule constraints with a high thermal performance that meets Seattle code and optimizes daylight and natural ventilation. We decided on a prefab panel that would span floor to floor, be locally sourced, built off site to clad both the office and resi program. Curtain wall with high transparency would only be used at level 1 retail, level 19 amenity, and the top floor. And some case studies that we used for this include the house at Cornell Tech, which is a passive house project, and Brock Commons. So we did targeted 3 portions of the building for on-site renewable solar, starting with the crown of the building, which was obviously the most efficient, the most access to the sky, oriented slightly southwest. We also looked at the western facade of the building, and which gets actually pretty good solar radiation. And there's various products on the market that can act as curtain wall or a cladding system that come with different colors. So we chose a blue color as an option for the rain screen of that facade. We also looked at the plaza, and just an additional opportunity to generate some energy with a BIPV that would bring in dappled light and some weather protection to the plaza. And this is just some elevations of what that would look like with that curtain wall in bands at the base, the middle, and the top, and the prefab punched window.
Sorry about that. So looking at, the financial and the constructability, phase 1 really could be done, while it's being occupied and really phasing in. But when you start looking at taking off the skin of the building, obviously that would start to shift at tenants and different stuff with that concept. So really wanted to think about the strategy and how we we're going to go about that. And we thought about starting really from the top down. And so phase 2 and phase 3 would have an overlap where you're doing the facade replacement. Having those panelized systems helped speed up the construction process. But then you could really finish up the upper levels while it took a longer time to finish down the lower levels. So, we priced in that overlap of those 2 phases and really got some good, synergies with being able to have some construction work support that really worked and made that kind of overlap and quick construction with the panelized system. We got great input from our subcontractors and we're able to, figure out and kind of escalate in the future based on our thoughts on when the construction would happen throughout the space. And so we'd start up at the upper levels with office space and really start to convert that space and starting to get into the solar production and really towards the net zero energy option.
All right, so we're going to transition into the mechanical story with Daryl.
Yeah, thanks. So we took a look at the existing conditions here and really tried to find the opportunities. So I'll talk through a little bit about what the existing conditions were and then kind of evolve into what we proposed. From a ventilation standpoint, there's 2 existing air handling units on level 19. And that space really was the heart of the building from a HVAC perspective. There were 2 existing centrifugal chillers that had recently been replaced and that we wanted to maintain in our concept. And then from a heating standpoint, there was electric reheat at VAV boxes distributed on the floor plates. One existing condition that we took into consideration, and you can see this slightly in the isometric view there, is that the tan ductwork risers, 1 air handling unit served kind of the central floors, and then a second air handling unit served the upper and lower floors. So there was some existing infrastructure there that we wanted to to leverage, and that kind of drove us to or contributed to that split between 80% residential and 20% office program. And we'll get into that a little bit more later when we talk about EUI as well. So you can see that it gets a little bit more complicated and complex, but kind of the main things we did here were we did coupled ventilation and with the heating and cooling system. So we added dedicated outside air units on the rooftop and at level 19. Rooftop units supplied air to the office on the upper floors, and the ERV on 19 provided ventilation for the residential floors. And then from a heat recovery standpoint, we added a heat recovery chiller in order to meet the demands of the heating and cooling for the entire building. And so adding the heat recovery component really drove our EUI down. That was one of our key ECMs. We served office spaces with hydronic gradient panels, and the residential units with 4-pipe fan coil units. Next. Thanks. So here's a little bit of a deep dive on our residential floor. We did some pretty detailed look at a unit. So each 2 units had a common shaft, and in that shaft, we were able to bring our HVAC utilities and plumbing utilities to the spaces. Each unit has a heat pump that will provide heating and cooling and manage humidification, as well as occupancy controls that turn on exhaust fans when the operable windows are open to really draw fresh air into the space when the unit's occupied. This is a focus on level 19. One of the things that I would say we were challenged with on the mechanical side was to vacate this level as much as possible. It was a 2-story space with views of the city, so it was prime real estate for Amenity. And so, as I mentioned with the electrical upgrades, we relocated the main electrical spaces, both the Seattle City Light Vault, main electrical rooms, and generator down to the parking levels. And then the transition from a central air handling unit concept really reduced our footprint. So we did maintain about 40% of this space, but was able to give back 60% to the amenity program. And on the rooftop here, you can see just quickly that you can see the amenity program up there with the green space. But so we really had to value the real estate there as well. So we added a DOAS unit, as mentioned, for the ventilation to the office on the upper floors and maintain the existing cooling tower. You'll also notice here kind of a structural shell for that solar crown that we'll talk about in a bit. From a plumbing perspective, this is a pretty traditional building. Electric water heating and domestic city water, providing all water to both for hot water, domestic hot water, and all the plumbing fixtures. And so shifting into the proposal, we added in heat recovery to this system as well on the wastewater side. And as well as a gray water system. So the gray water system actually served to provide all the water to toilet flushing, the residential washing, as well as cooling tower makeup water. We were able to eliminate the electric water heating, and the heat recovery from the wastewater system supplied all the hot water demands for showers, sinks, and the residential washing machines. This goes into a little bit more detail of the build out of the electrical system. So you can see on the left in our diagram, it's very basic. We had a utility connection, it's power distribution, and a generator. And so moving into a more evolved system, you can see the photovoltaics from the solar crown, the building integrated PV, as well as the canopy down at grade, plugging into the system, as well as batteries. One thing here that's I would say kind of an extrapolation from a residential application is the idea of electric vehicle charging fleet. And we wanted to leverage that as actually an energy storage medium for the project. And so we proposed a fleet owned by the building that is available to the tenant under their lease, but it also could be, become not available and leveraged as a energy source and when in need. So that it kind of extrapolates the idea of a home being able to have solar or a utility connection to charge a vehicle, but then if there's a loss of utility power, you can leverage the energy stored there to keep your house running. So we kind of extrapolated that application. And there's a lot of technology out there with vehicle to grid charging that will actually allow for this to happen here in the near future. And last, kind of continuing on with that enhanced technology, is a lot of the systems and things in that bullet list is already in place in buildings. And so being able to bring that all together and harness that for very specific use cases is important. And so this is kind of just an introduction to it, but really that's more of a process, and trying to talk about what is the best value to each individual building, each individual manager, building manager, owner, to understand what information can really supply them with the best value. So that could be, being able to provide feedback for energy reasons. It could be for documentation purposes for certifications like LEED or WELL. It could actually enhance their safety if you integrate some of their security systems. So being able to plug in these sensors and utilize all the data and bring it into a collective place, and then provide that in a usable manner, either to end users or owners or the like, was a key piece of our story.
So here's just a rendering of one of those leasable office spaces at the top of the building. Same program, same space is in the building now, but with that reclad. And you can see one of those seismic dampers. And now each window has gone from a 7'6" head height to almost 10 foot. So we're bringing daylight deeper into the space. We're underneath the 40% window wall ratio target for the updated Seattle building code. And so, we've got great natural ventilation, the DOAS, and daylight. And then here's just a rendering as well on the top floor, the amenity of that public open space, which is really thought of as a vertical extension from the plaza at the podium, with huge sweeping views of West Seattle and the Olympics beyond.
Right. So when we were looking at phase 3, at the end, ultimately that office space would be able to be rentable, and the upper area would start to bring in income. We started also looking at this point to start taking some tax deductions and offsetting some of the costs that would be associated with all of these modifications. So really finishing up that exterior renovation and getting the office level HVAC and all of the amenities built out, and that solar crown up there with the park, it starts to generate revenue, and then we're able to finish up the residential before or after that phase. We looked at, then being able to bring occupants up through a separate elevator corridor while the rest of it was being worked on. So we used a lot of unit price information, contingency and escalation accounting, as well as subcontractor input for kind of more specific mechanical and electrical systems that are not really a unit rate sort of information. Phase 4 residential conversion. So really this is a little bit longer phase with really doing the build out. But we kind of split it up into kind of 3 sections, hoping for some phased occupancy to really help kind of offset some of those costs of bringing back in revenue for the potential of this sequencing, and really freeing up that mechanical space as we're working through to be able to have that amenity space available.
Yeah, so down at at the ground floor, there's a great plaza. This is where you can pick up buses on 3rd Avenue, and so there's also a setback in the original Graham design that we filled in to get maximize the space at level 1 for pop-up shops and various retail. We also added a daycare just to help activate the building and be an amenity We split the current lobby into two, and we're able to reprogram the elevators between the high rise and low rise for the resi, public space at the roof, amenity. So this is at level 19, where Daryl noted that MEP was able to give us 60% space back on this incredible two-story high space, where we could develop a bunch of resi, lounge, gyms, fitness for the recreational requirements per the zoning code for residential. And just a view of what that might look like. And this would have, again, operable windows. This is more of a curtain wall system just to increase transparency. Oh, sorry, I was one slide off there. There it is. So here we have just a couple options for what that residential planning could look like, where it's working with the structural grid. It's quite modular for different 1, 2, 3 bedroom options. We're stacking, we've added 8 new shafts with back-to-back kitchens and baths. And then here's just a daylight study to show, again, with those 10-foot high windows, bringing in daylight as deep as we can into these spaces. And just a rendering of what one of those apartments would look like.
Great. So we really leveraged our kind of room finish model that we use at Lewis. We really take a look at kind of each type, figure out the square foot and unit rate cost, and then kind of multiply that. And so we were able to kind of be flexible and look at different unit sizes and information in different floors, by able, to have those kind of unit price information per type of unit, really find out the best mix we felt would work for this situation, where we were encouraging family living with the kind of larger units, as well as having the smaller units available for more singular occupancy. The modular construction helped kind of speed up the schedule, and we were able to really look at that. But again, we looked at kind of, breaking up the levels with the hopes that maybe we could start to occupy and have those available to bring back in revenue for the building. So overall, the project, expenses with just looking at the time frame, escalation, all in, we were a little over 280 million for the overall conversion. And then we had some offsets with taxes and benefits that we were able to calculate back off of that. We really took a look at, each section of the demolition, the residential conversion, got the plaza PV, and then ultimately that amenity space, which is really beneficial with those huge open floor plate that we've got.
So,
Chris?
Yeah, given the regional economy's need for more housing and the fact, that the offices haven't been fully occupied during the pandemic, we investigated really what the optimal mix of office and residential programs might be. And when we explored options, we didn't really find the significant direct energy saving synergies, but really found a solution on the right that really was optimized for the way we're doing the phasing and installing more efficient MEP and the other upgrades we had to make. And it also, as we'll see, ultimately reduced the project's overall carbon footprint. So on embodied carbon, in the energy. So here you can see the ultimate energy efficiency. So going from a baseline load, which we calibrated to the existing building energy use, and for our new program, and reduce the EUI to under 19. And you can see the ECMs where heat recovery, energy recovery, and the envelope were really significant. So ultimately, you can see our on-site PV contributing about 30% of the overall energy use of this tower, with the rest coming off-site. And so this diagram is reflecting the embodied carbon reduction. So we were looking at, for the new systems, for envelope and seismic really being efficient in the material choice, But overall, we also valued the sunk carbon that the existing building represented. And so net, we're calculating the whole building at about 15% lower than the CLF whole building baseline. And our emphasis on embodied carbon also extended to our offsite renewable strategy. So when we looked at the remaining need, we compared offsite PV to a wind turbine. And the wind turbine was the winner. Not only did it diversify the timing of supplied energy, so more valuable than the PV, it used far less land, and the land underneath it, of course, could be used for other useful purposes. So we thought this was a large advantage. And really, the ultimate focus on carbon, when we did the analysis, the big impact was commuting. And even though Seattle office commutes actually nationally are some of the more efficient, highest use of transit, or one of the higher uses of transit, when we look at the overall lifestyle and we compare people living in the suburbs and commuting downtown versus downtown residents, the Seattle data shows that living downtown greatly reduces a Seattle resident's carbon footprint. Walkability, is I think close to 80% for people and families living downtown. So this was a big reason for us from an overall sustainability perspective to investigate what it meant to make this tower primarily residential. And so the result is a proposal that not only enabled best-in-class energy efficiency, an approach for net zero, but extended the investment of the sunk carbon inherent in the program. So our proposed renovation not only cuts life cycle carbon emissions by 75% over the next 15 years, assuming the 60-year life of the building, but it enables it to last longer. And we're estimating at least another 50 years beyond that life with the improved seismic structure.
Right.
Go ahead.
We're looking at the complete financial. I know it's really small, but it's just really meant to show kind of, we looked at different options as we were going through and looking at concepts, and we're able to kind of try and quickly price and decide on some different things, and looked at the different residential options and some other things. And so this is just a log that we kind of kept, where we said, okay, we're accepting this, we're going to move forward and do finite more detail on this budgeting and this information and phasing of the overall project. And then we also looked at the savings information and be able to calculate that in. Overall, I did say we had about 280 million. That's an escalated kind of concept of timing. And if you think about, if you were to ultimately replace the building at the end of its life and do that calculations, it's significantly more if you were going to build a new kind of shell and core office in that space in about 10 to 15 years.
Great. Well, that brings us to a conclusion. I think we can open it up for a discussion.
I think one of the, I'm just putting this out, I think one of the building owner just wanted to sort of make it clear that these changes are not going to be made. This is kind of like a thought exercise, I guess. So I just wanted to put that on the record.
Yeah, it made it really fun to just be kind of, be able to think out of the box and not really have any constraints with that, and have a competition that was really, something that could really be just thinking about innovative ideas in different ways, that maybe some of these could be applied to different buildings as well. Yeah,
absolutely. I think, Amy said it before, this was an exploration of the opportunities. If you're going to be looking at, net zero futures, why not look at these different intersecting systems, whether it's the seismic or it's the reclad, improving health and wellness, repositioning a property. It was a blue sky kind of white canvas opportunity. I think the 2030 gave us to have some fun, really take a look at the city and, what can it do going forward?
Don't be shy if anybody has any questions.
Well, I'll go first. This is Medgar Marso with Morrison Hirschfield. How does the cost, and I don't want to be a downer here, but how would the cost compare, maybe carbon and like dollar cost for building residential somewhere else, like starting from new?
Well, I guess, yeah, the first would be that, as was mentioned, building new is always going to be way more expensive. The biggest thing that we were trying to leverage, other than the downtown transit system and walkability, was the sunk carbon, as Chris noted, in the building. I mean, there's significant amount of steel and foundation and structure in this building that is, it's already up in all the emissions are up in the atmosphere. So, to leverage that and extend that useful life as far into the future as possible was at the heart of this adaptive reuse.
Yeah, and I'd say, cost wise, we looked at really just at the existing building and replacing it with office, not necessarily with residential. But if we were looking at, in 2040, kind of where we would look at this as an end of life and build a new structure there, it was about 450 million, based on current rates and escalated at a reasonable rate, not current wild rates. And so there was a significant cost difference if you were going to build a new shell and core office space, versus doing these kinds of upgrades over the next couple of years. Does that answer your question? Or
yeah, that's great.
Okay.
Just another note, during the competition, there was a New York Times article that came out that, a lot of central business districts across the United States are really long and heavy in office and short on resi, and that how non-resilient that is. And, there's a lot of markets that are struggling with leases. I don't think that, not necessarily Seattle, because we're flush with, high tech and there's lots of money here. But in other cities, there isn't. And pivoting to residential is just a potential option for a developer or owner of a site. So I think this was not meant to be, you need to, switch over to resi, but can that be an option in your toolkit moving forward?
Yeah, and just the resiliency, I think, of not only the building structure, but just the occupant load.
This is Josh with Northwest Energy Efficiency Alliance. This is really, really impressive and kind of exciting and fun. Can you talk a little about your decision around the dedicated outdoor air system? Is that something, I'm curious if that's something that fits this particular project well, or if that's just something that you folks generally think is just the right path in most projects going forward?
Yeah, I would say a lot of the drive had to do with trying to introduce heat recovery and decoupling the heating and cooling from the ventilation, and leveraging some natural ventilation as well. So probably the key drivers, I would say, that guided us through this, as well as I think we might have looked at it a little differently if the program hadn't been what it was.
I see. Okay. Thank you.
Certainly also supports, moving towards just fresher air, higher quality for, health and wellness.
You touched on lighting a little bit. What I did see, obviously, a reference to kind of networking. I assumed your lighting system was some sort of network controls, or were they luminaire level controls, or just general NLC? Or can you speak a little bit more to some details around the lighting, if you went that deep?
Yeah, we didn't go into a ton of depth there, but absolutely the opportunity is to leverage PoE lighting now as you kind of work into smart buildings and being able to hang sensors off of that lighting system. The capacity in which you can put, or I guess the allowed capacities on PoE switches is increasing. And so the opportunity to do that more broadly in projects is a key driver. So we didn't get into that detail too much, but it was definitely kind of a component of the smart building idea and concept, is that we'd have luminaire level control, and then also being able to hang sensing devices off of that system as well.
Got it. Thank you.
Any other questions?
Hi, this is Ryan Entenson from the AMA group up here in British Columbia. This is an inspiring design. Thank you for the presentation. I'm just wondering, normally up here in our building inventory, there's not a lot of mixed office and residential space, at least in the downtown core. And I'm wondering how much of a co-benefit do you get in your heat recovery chiller for having mixed office and residential space? Is there a lot of cooling in the office space during sort of tepid outdoor air conditions that let you heat the rest of the residential spaces?
Yeah, I think there's opportunity there. I think there's challenges with kind of the timing of the heat recovery and being able to leverage that maybe more at that transition time between the occupied office time versus the occupied residential time of day. I think we identified the kind of the water system as being the or I should say the domestic water system, and the wastewater heat recovery is probably the better leveraging point for that between the two programs.
Right.
Because we did have some storage opportunity there, where with the heating and cooling pieces, you don't have that opportunity as much.
Right, because you already have the wastewater tank where you're able to store a lot of thermal energy.
Correct.
Did you investigate thermal storage just on a space heating and cooling side to be able to sort of deal with that timing issue?
Not in too much depth. We were looking at probably more other opportunities from a programming standpoint. I know we looked at more computer room data center for heat recovery purposes, and it kind of just sort of got to a point where it was the right fit, as it all kind of came together when we landed on the programming split of 2080. That a lot of it kind of gelled, and we're like, well, we don't really need any more heat recovery from a heating standpoint. So we've kind of moved away from a data center within the building. So it kind of, I think, sort of evolved to a point, and then we kind of landed on where we did, because kind of all the things pointed to we could be kind of this self-sustaining heat recovery system. We also looked at tapping into the city's wastewater or sewer heat recovery system for heat system for heat recovery, and that just didn't pencil out when we were doing our energy modeling. So
right.
Yeah, I mean, a lot of analysis, but from a thermal energy storage standpoint, we didn't talk about that from a what I've seen, I guess most exclusively would be storing that in a water system, right? And
Right.
I think the real estate in this building, above grade was, high value, and we didn't actually look at that from a garage level. I think we were really focused on trying to drive the electric vehicle story a little bit more.
Right, I see. Thank you.
Anybody else have questions?
I can make a comment. This is Charles Kelly in Portland, Oregon. I think this is such a powerful move for at the scale of a city to convert buildings that are nominally used for a single use into a mixed use building that can populate the downtown with people in areas after work to kind of bring some energy and life to the street level. And I think can maybe even begin to start to compete with some of the lovely neighborhoods that people are now occupying during post-COVID, who are really reaping the benefits of a pretty strong service industry, just outside where they're working or living. And I think this is kind of a really great indicator of the policy shift that could occur in the city zoning to get the downtown to start to compete with some of the centers that have developed post-COVID. So I'm just applauding this analysis, just another good reason for why we should invest in our downtown. And I want to just thank everybody for providing that analysis.
Anybody else?
How much do you think this will affect future development downtown? Both new buildings being mixed use and actual conversion of office space?
It's a great question. I think when we set out for this, there was a thought to just kind of come up with a toolkit, a playbook, in a sense that looking at other cities like New York City, which, much more developed city that has gone through a lot more reclads than Seattle has. And, just looking at market forces and opportunities that New York has exploited and New York developers, and also looking at New York actually for affordable housing and other policies that I think they're much more advanced than we are. They've been around. And so, I think that a lot of this is going to be a mixture of forces between COVID is really rewriting a lot of our rules right now, because downtown is still pretty empty. And, it's hard to look in the crystal ball and know what is, what should people be doing as we have new legislation coming to potentially decarbonize and go all electric throughout Washington State. What does that mean? And other forces that aren't necessarily just an MEP fix. I don't think it's just a go caulk your window and, you're done, or change out your heating system. So I think this was an opportunity to really just kind of step back, look at all these forces at once, and there's going to be optimization on a case by case, property by property, owner by owner. I think it's hard to have a one solution fit all for downtown Seattle. Third Avenue is a really interesting transit corridor and has its own vision process for the city. So how can we engage that? Like Charles was saying, how can we really think urbanistically? To honestly put a lot of resi downtown, I think we need more open space and schools. So there's other infrastructure that needs to come in parallel with just a parcel by parcel kind of fix. So it gets back to this district question. Like we really need to holistically look at the district and the city and make policies that are friendly to the developers and the owners, but also are engaging with our housing crisis, our COVID crisis, and making just our city more resilient.
And
What I like about this is it takes a lot of human brain power to come up with this and to do this, and instead of using products and technology. So it's like more jobs for people like us. It's more jobs for people to use their brains and collaboration and knowledge and that sort of thing. So I think it's awesome.
is it okay just to follow up on Megger's point, just in a conversation? Is that okay?
Please.
I really think that Megger's onto something here. I think this is like 2030 districts is really about building a community of, tenants and building owners in a community in the downtown. And I think that is now expanding to a broader community that's served by the benefits that are returned by just the actions of that community. And I think you're just trying to, like Marty, what you're saying is you're just increasing the number of participants who have a vested interest in the success of this area if you're going to invite them to live there, right? And yeah, you'll have neighborhood associations, you'll have, Lord knows the conversation that is going to, improve about how to form the neighborhood. And I think moving from automation and technology to the sense of this community is kind of the shift. That's what the paradigm shift that happens across this project that I find really intriguing. And I think Megger is right on it. It's about building a better community.
And it's such a great point. That view is different when you're on the inside looking out, right? Like a group of people is actually living in that community and really seeing what it is they need day in and day out. So really, putting ourselves in the shoes of that person as we think through this is so valuable.
I think we have some opportunity with, the waterfront revisions, and, it's not like we can kind of sprawl out like some of the other places we're constrained by water on a lot of sides. So, I think just reimagining, what we have and how we can work with what we have, and really just getting those ideas out there. Not every developer or owner is going to take this full sweep, but it gives at least some ideas and some thoughts. And I really appreciate the 2030 district being able to bring everybody together to have this kind of discussion and thought, and kind of think outside the box without constraints. It really, I think it is great. And I appreciate having the 2030 district host this competition.
I just want to say on behalf of the 2030 district, all of the teams were amazing and dedicated and gave so much of their time. And we can't thank your team enough too for the extra step that you've taken to help us create this video. And also just on behalf of Anne and myself, Cassandra was out sick today, but just want to thank Cassandra Delane, our ED, who carried this on, and Matthew Combe, who had the great idea. Neither one of them could be here this morning, but the district's really grateful to all of you. And yes, we're going to be promoting this. I think there's a lot of applications we can look at, and especially want to really appreciate your attention to detail where seismic is concerned, because I think at a different scale, we could be looking at this in Pioneer Square and the International District, where we have a high concentration of URM buildings. And of course, when you go to do those seismic upgrades, it triggers the energy upgrades. So hopefully we can find some funding to look at this, take a deeper dive from a scale perspective too.
Thanks, District Carbon team, for presenting, and congratulations. Thanks everybody for attending. I'm going to stop the recording right now.
Great. Thank you.
Thank you.